Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the most dangerous failure in AI. Not because the model is wrong, but because when it's wrong, it looks exactly like when it's right.
Let's start with the word itself because hallucination sounds like the model is lying or glitching. Is that what's happening?
No. And that reframe is the key to the whole topic. A hallucination isn't the model malfunctioning. It's the model doing precisely what it was built to do. Predict plausible next tokens. When it doesn't actually know something, it doesn't stop and flag it. It just generates something that sounds right. Fluently, confidently.
So the fluency and the hallucination are the same machinery. It's not that it knows and lies. It never knew and it filled the gap with something that pattern matches to true.
Exactly. And that's why it's so dangerous. The wrong answer is indistinguishable from the right one. Same confident tone, same polished sentences. There's no tell. So the defense is grounding. Tying the answer to a source you trust. And the real skill is measuring whether that grounding actually held.
Define grounded for me precisely. Because I'd assume if you do RAG and hand the model a document, the answer is grounded by definition.
That's the seductive mistake. An answer is grounded when its claims are supported by a source you trust. The retrieved context, a tool result, a document. RAG is grounding by construction, yes. But grounding is a goal, not a guarantee. The model can still ignore the context you gave it, overread it, or blend it with something memorized and wrong from its training.
So you handed it the truth and it can still wander off, which means you can't just trust that it used the source. You have to check.
You have to check, and not by eyeballing it. The reliable method has a name and a shape. You decompose the answer into atomic claims. You break the response into its individual factual assertions, and then you label each one against the source.
What are the labels?
3. Grounded, directly supported by the source. Contradicted. It actually conflicts with the source, and that's the dangerous one. And the sneaky middle one, inferred. Plausible. Sounds totally reasonable. But it's not actually in the source.
And then faithfulness is just the score you get from counting?
Right? Faithfulness is the fraction of claims that are grounded. Grounded divided by total. Let me make it concrete. Say a model answers a question about a refund policy with 4 claims. Enterprise refunds within 30 days. That's in the doc. Grounded. Refunds prorated after 30 days. Also grounded. Refunds processed within 2 hours. Sounds fine. But it's nowhere in the source. That's inferred. And there's a 60-day extended window, which flatly contradicts the doc.
So that answer reads as smooth and authoritative, but it's only 50% grounded, 2 of 4. And one claim actively contradicts the source. Any contradiction is basically a red flag on its own.
That's the whole point of decomposing. A fluent, confident answer can still be mostly air, and you'd never catch it reading holistically. And this is exactly what the RAG-AVAL frameworks automate. Ragas, Trulans, DeepAVAL, usually with an LLM judge that extracts the claims and verifies each one against the retrieved context.
Okay, but I want to push on something. If you're using an LLM judge to score this, and LLMs are the things that hallucinate, is that score actually trustworthy? Where does it break?
That's exactly the right worry, and recent research is blunt about it. The blind spot is precisely that middle label. Current evaluators struggle to tell a genuinely grounded claim from a plausible inference the model made. The contradicted ones are easy to catch. It's the inferred bucket. Plausible but unsupported, where the evaluator itself gets fooled.
So a score like faithfulness, 0.9 is hiding the most important question. Is that missing 10% a harmless paraphrase or an invented specific that someone's going to act on?
You just landed the entire caveat. A single scalar number blurs those two together. A harmless reword and a fabricated detail both just lower the score a little. So treat the number as a signal, not a verdict. And for anything high stakes, look at the per claim labels, not the percentage. Because the inferred bucket is where the quiet hallucinations live.
Alright? So, given all that, what actually reduces hallucination in the first place? Before measuring it,
The biggest single lever is grounding it properly. Retrieval plus an instruction that says answer only from the context. And if it's not there, say you don't know. On top of that, ask for citations. Make the model cite which chunk supports each claim. Then any uncited sentence is your prime suspect, and it makes the whole QA process trivial.
and for the things that don't need to be prose, structured facts. You'd constrain it instead of letting it free write.
Right. Constrained decoding and tool calls beat freeform prose for structured facts because there's simply less room to invent. And the last one is cultural as much as technical. Calibrate uncertainty. Encourage I don't know over a confident guess, and actually measure how often the model abstains when it should. A model that knows when to shut up is worth a lot.
So the one sentence to walk away with
Hallucination is fluency without knowledge. So you fight it by grounding answers in a source and then measuring faithfulness claim by claim. And never trust a single faithfulness number because the quiet hallucinations hide in the claims that merely sound supported.
ground it, then check every claim. That's the Datarekha audio guide. See you in the next one.